Okay, so please make sure you have this in your plan book. If you had turned in your math journal, it is on the back table, if you have not gotten it back yet. If you did not turn in your math journal, hey guys, I'm talking about that. If you did not turn in your math journal, you have through today to get it turned in before I post grades in math. Okay, so if you get it turned in today, you can still go in without ever having progressing, missing, anything like that. But I got to post grades soon, so I figured I'd hold off till this evening, give you one last chance to get it turned in. So math journal check 3. If you've not had a third journal check, you need to turn that in. Plan book, please make sure that's in there. The forms you picked up as you came in. So these homework forms. Right now, please everybody put your eyes on this. And I guess I'll give Kate's back so she can do this. Please put your name at the top of that, where it says name. Notice that there is a section for each day, right? So from Monday, from Tuesday. This is where we're going to keep a little. This is where we're going to keep a little log of your homework. So not only is this going to be a feedback form for me, but it's going to be a way that you know what's going on. So for today, what do you think you could go ahead and fill out on this form? What's your homework for today? So over here on From Monday, where it has the hashtag, that again means number symbol, you can fill in 7, 8, 9, 10, 11, and you'll have an empty open box still left. Then as you go through the homework, or tomorrow I'll remind you to do this in class, we will be checking your answers. Now, I may end up just posting answers as we get further into the year so that you can check them on your own. But when we check answers, you'll then mark whether you got it right or wrong. Notice on the columns there, I got it right, I got it wrong. And then, even if you got it wrong, do you now understand it, or are you still confused? So we're going to start quickly going over homeworks every day when we meet. We're going to be filling out this as we go. So you need to keep track of this. I'll be collecting this on Fridays. That makes sense? Just a little feedback form. So a lot of times the From Friday may not get filled out, or I might give you a new one on Friday, and then you start on Friday and then loop back around. You can also date each of these days if you want to, besides from Monday, from Tuesday, from Wednesday. You could date those as well. Any questions on this? Just quick little checks in boxes. Do you get it? Did you get it right? Do you understand it? Are you still confused? Because this will let me know what do I need to go back and revisit. Some of you got progressings on your math journals because you have written in there, I don't know, I need help, I don't understand. Because for multiple days, we took homework questions. You cannot turn in a math journal still saying, I don't get it, I need help. We, for 2 days, took questions. So that doesn't fly. Okay, we're too far into the year. Any questions about the homework feedback form or anything else? We are now officially in quarter 2. So if you would like, and honestly it'd be my preference, but it's totally up to you, you bought for my class from the supply list 4 journals specific for math. So you may switch to a new one of your journals, assuming that you have kept track of those. Now if you use them for something else or lost them or whatever, you're going to have to negotiate that on your own. You do not have to keep using the same one. We're starting a new chapter. We're starting fresh. We're starting a new math journal check. So if you want to, now would be a really good time to switch over to a different math journal. Today we're going to work in your toolkit, right? We have pages in your toolkit that should be open. But for your homework tonight, you make the choice. Am I going to keep working in the same math journal or switch to a new one? Please do not switch to a new one 3 days from now, because then you're going to have work in the old one and work in the new one. Like if you're going to switch, switch. If you want to switch and you don't have a math journal, come see me. I, through years and years of being a pack rat, have plenty of journals to offer up. So this is like there's a stack behind those too. So come get a journal from me if you need. I got a lot. Yeah. Can you what? Oh, you shouldn't need it in classroom because we'll be working toolkit to take notes. So please open your textbook if you have yet to do so, and open your toolkit. We are, I don't know what student page it is. 311 is page 130. Who's got it? 31. 131. be what? 131. So we're still talking about Cecil's tightrope. And now we're expressing how far he goes in a different manner. We're kind of killing time waiting for people. We're still flipping, still getting where we need to be. In our toolkit, we should now be on page 26. Oh, we can start before that. 24? 22? We have a lot of graph paper here. Yeah, we can be on page 22 in our toolkit. So we have like 6 pages of open note space here to start. So you shouldn't need your math journal today. You should just need your toolkit and your textbook. The math journal you should not need till home. I need to go over with one of the 3 groups. Either of those 3 groups, just so you know who to work with. You just jump up and move. So go ahead and check out problem 3-1. We're talking about Katrina, and she's writing the moves for Cecil. And we want to figure out how long is that tightrope then going to be. You can choose whichever group. Doesn't matter if you Francesca's group or ours. Really, there's the all boys group, and then boys and girls next. So whatever you want. What's this dot mean? What's that dot mean? Multiplication, right? So read through your 3-1. I'm going to give you a couple minutes. Read through 3-1 and talk with your team, see what you think. I can get out more pencils too. Should have thought about being Monday. I have a feeling this lesson may turn into a 2-day. Today is the 23rd, yeah. 10/23. All day long. Can anybody identify what's wrong about the diagram of B? Or can you tell me what that diagram is actually communicating? Alex?
She said 2.5, 1 times 2.5, and then plus 1.
Okay.
The 2.5 plus 1 should have both been in parentheses.
Ah, so this tightrope, you're saying, would be 4, and you said in parentheses, I'd have the 2.5 and the 1. Okay, how's that different than what was written up here? I mean, obviously the parentheses, but how does that affect it?
It makes it so that you do the 2.5 4 times and the 1 4 times.
Which does? The way Katrina had it written or the way that we did it?
The way that we did it right now.
So then in D, Cecil changes stuff around. Now still it seems like Cecil is interpreting this slightly differently. Anyone tempted to get out the cards, but I'll still take volunteers right now. Can anyone tell me what happened in D, what Cecil did, and how his is different? Liam?
He put the 1 and then 2.5 and armed them together, so like multiplying the 2.5 4 times, and then the 1.
So did he do the right thing? Like, did he go the right distance? What did he do, though? So he went the right distance, but he didn't do what we expected. You said he put the 1 first. He just changed the order, right? What do we call it when we change the order or move things in addition or multiplication? What does it mean to move? Starts with a C. We have that property name, Marvin. Commutative property. So what Marvin did, or sorry, what Cecil did, and Marvin identified, is Cecil now up here, instead of saying 4 times 2.5 and then the 1, Cecil said 1 and then the 4 times 2.5. Does that make sense? He just did it in a different order. He wanted to start with a short move. Is that allowed? Does it change our answer? Yeah, it doesn't change anything, so it's totally allowed. Commutative property works for addition or multiplication. Either of them. So let's try 3-2. When we're looking at the tightrope here, Cecil has now put the individual move in A and B out front to make life easier. C, you got to figure out C. But in A and B, he put the individual move out front and then the repeated moves. You need to figure out how long the tightrope would need to be for each situation. So for A, B, and C. So I'll give you just a couple minutes. We can probably get through this in like 2 to 3 minutes. So what you're answering is, how long will this be? Now, you used to thinking of PEMDAS. What did I ask you to think of instead of PEMDAS? You don't remember? Instead of P for parentheses, I prefer. I don't know if I told this class then. I'm getting a lot of confused looks. GEMDAS for grouping symbols. So you guys are used to PEMDAS, right? For order of operations. And if you write it correctly, it's going to look like this. I prefer, instead of P for parentheses, G for grouping. Now, this doesn't matter right now because we don't have any other symbols. But we will eventually, instead of using that P, we'll use a G and call that GEMDAS, which really just means all grouping symbols happen first. So, in my parentheses here, Eleanor, inside my parentheses, is there anything for me to do? No. So then I worked out my order of operations. What's the next thing that I should do? Multiply. So I multiply the 2 times the 6.8. Then we'll get that value for how far those repeated moves took us. Then we will add the 8. What'd you get from there?
I got 12.96 for the multiplication.
Yeah. So in total, we get 20.96 feet because we got 12.96 from the repeated moves, and then we added the 8 and got 20.96. Nathan, what do we do in B?
Multiply 8 by 6.48.
Mm-hmm. And then we'll add the 2. So when we do this multiplication, we're gonna get, this is pretty close to 6.5. So you can do some approximate math, but if you use a calculator, Anyone have what you got from the 8 times 6.48? We're just all waiting for somebody else to do the work for us. Guys, if you need a calculator, get up and get a calculator. I'm not doing this for you. I'm making a stand right now. I'm going to make a stand by sitting down and waiting for you. I'm not going to be that teacher that says you can't use a calculator, but I am going to be that teacher that says you can't wait for somebody else to do the work for you. You got to be comfortable solving these things. You got to be comfortable punching into the calculator. There's something therapeutic about punching the buttons on a calculator and making it think for you. Okay. 53.84, was that just this multiplication? Or was that with the plus 2? With the plus 2, sweet. 53.84 you said? Thank you very much. Now, C. Alan, what's up with C? What do we do to solve that?
You do 8 plus 2, right, since it's in the parentheses.
Okay.
And then you do 10, well, 8 plus 2 plus 10.
Okay.
So you do 10 times 6.48.
Sweet. So 10 times 6.4. I know multiplication with 10 is easy. I just shift to the decimal point. So I get 64.8. Here, the order of operations actually really matters because we have grouping symbols that want us to do the addition before we do anything else. C is that different situation. So our longest tightrope is obviously situation C. Move on to 3.3. Try this. Remember when working with our algebra tiles, I was actually talking with a friend about how much I love the algebra tiles this weekend. I'm not joking. I was seriously talking about algebra tiles. The real question here is, can you see the map? Do you get how we go from the written numbers and turn it into this? So take a moment, really investigate. Do you see where, like, how that happens, why that happens? Talk with your team. Take about a minute. Then we'll use your card to have someone share it. Who can explain this to me? Any volunteers? I got cards, but... Grant?
I see them as like 3 different groups.
Okay. How would you split them? Would I like split vertically or split horizontally? Or... Explain your groups to me then. Sorry.
Alright. So the first I had 5. Plus 4 parentheses 3.
So I would actually argue... Now, this doesn't make a difference, and it's in your head.
Yeah, I know.
I would argue 3 parentheses 4, but 4 parentheses 3 will get us the same thing. Why? We're like, it's the same. Why does it matter? What is it? Like, it doesn't make a difference, right, Annika? Well, yeah, it's just 2 numbers and just multiplication. That's why it doesn't matter. Why might it matter for how we're trying to describe it?
Because there's not 4 groups of 3, there's 3 groups of
If I'm trying to tell somebody how I see this, I see 3 groups of 4, not 4 groupings of 3. Now I could rearrange these and make 4 groupings of 3, but what I see is 3 groupings of 4, which is why I would prefer to write it that way. And then, Grant? And we've just got 2 more, so we've got 5 and 3 groups of 4 and 2. Do we see how that works with our tiles? If we were going to try to build it and visualize this. Obviously, we could just plot down that many tiles on the table. But by separating and grouping, it makes sense of what we're doing. So let's move on to the little bit more difficult one down here. Could you draw that, or could you explain it? Take a moment with your team. Could you explain or draw what this is representing? I want you to try to draw it out. Emma, if you were going to try to explain this to somebody but couldn't just like show them the math, how would you say it?
There's 4 groups of 5.
All right, hold on. So there are 4 groups of 5, and we know those are positives, right? So okay.
And there's 1 positive. And then 3 groups of 2.
Ooh, 3 groups of 2 negatives. And then just 6. Does that make sense how Emma explained this? We would see 4 groups of 5. We would see an individual 1. We would see 3 groups of a -2, and we would see 6 positives on their own. Now, if I go to try to simplify this, what can really help me simplify? Patrick?
In the right side, there's 6 negatives and 6 positives. So it's basically, you're going to like, right when you see someone going forward and backwards, you're just going to be going nowhere.
Every positive negative pair, what do we call this when we have the same positives as we do negative? 2 words. Additive inverses. So we have additive inverses here. We have a -6 and a +6. These cancel each other out, and this is really 0. So what do we have left? Well, we have 0 from these guys. Was that the only thing we did? So we're really left with all green. I hate you, green. Now it wants to work. Maybe? No. Hey, there it is. We're left with these guys, which will give me 21. Questions? I'm going to try to recenter this to take a snapshot. Now, you do not have to draw it out to model it, but try A through D. Hopefully you have a calculator. Try with your team right now. You can split them up. You can do whatever you want. Try A through D in 3, 4. You don't really need a calculator. I would challenge you to try with that. kind of had an abbreviated class today because we lost some time with form this morning, but I think we're okay. So we've got about 10 minutes left. Or not 10 minutes. We've got about 8 minutes left. Try your homework tonight. We'll take questions to start class, but we're not going to make this a 2-day lesson. We're just going to try to keep rolling. So essentially, the main focus here is order of operations. So try these problems. If you get done with 3-4, move on to 3-5. I'll bring you back together in about 3 minutes. Talking trash over here. Yeah. You say, yeah. As you're holding a calculator. Exactly. Remember our good guys, bad guys? We can group up good guys or bad guys before we start fighting. Now that analogy gets a little skewed right here because be careful, that's really the good or bad. What I highlighted is really going to come out to be bad because positive times a negative makes a negative value. So if we had 2.1, 2 and a tenth, groups of -3, we come out to be a negative. That ends up being -6.3. So be careful with that. Aubrey and A, if we group up the positives first, if we group our good guys together, what do we get there? So break it apart. Make it easy, right? So what's your 7 and your 2 added together? 9, right? So we'll start with 9. Then look at your partials. I have 8 hundredths and 51 hundredths. Well, hundredths and hundredths, so I can put them together. What's 59? So 59 hundredths. Then we got the bad guy. -3.84. They fight. When they fight, who's going to win? Did you have a question? Answer? Oh, do you have the answer for this?
Yeah, I had 5.75.
Yeah, because the partial here is bigger than the partial there. This is dangerous subtraction. So even if you do it on paper in your head, I would verify it in a calculator. We get 5 point, what did you say? 75. Can you even verify that? I just like when we take answers in class, I like to get it from 2 different people because we all make mistakes. Any of us can make a mistake at any given time. So we like to check our answers. B. Kate, what do you got for me for B?
Well,
I already did the negative part. Times?
no, plus.
So what do we get then? Who's winning, the good guy or the bad guys? Good guys are going to win, right? 7.8 is stronger than 6.3. The difference between them, 1.5, right? Zoe, what about C? Now C is kind of awkward. Did you guys get to it yet? Okay, so help me out then. What can I do with that multiplication that I see to start? I have a whole number and a fraction. Do you remember what we did last week to deal with multiplication, whole with fraction? What could I do with the 5 to make my life? Yes, we put a 1 under the 5. So this turns into 5 over 1 times -3 over 5. Then plus the 2 times 1.5. How do we multiply with fractions? We already chatted. Francesca, how do we multiply with fractions?
Well, you multiply 1 and 5, and then you multiply 5 negative.
Straight through, right? When you think of multiplying fractions, think of straight through. People like to make the mistake of cross multiplying. We haven't done that at all yet this year, guys. We've not talked about cross multiplication at all. We don't use it yet. When we multiply with fractions, we just go straight across. Cross multiplication is when fractions are equal, and we'll get there. But please don't think that we're doing that yet. So we go straight through. We get a negative 15 over 5. That looks like that division will work out nicely. This multiplication also needs to happen. What's 2 times 1.5? Oh, come on, guys. Try again. 2 times 1.5. 3. Hey, if you're going to be wrong confidently.
Yeah.
So then we get 3. What's negative 15 divided by 5? If I have negative 15s and I break them into 5 groups. Negative 3. So I have negative 3 and positive 3. And it makes 0. Because these are? Yeah, additive inverses. Don't say it quietly like you're scared. You know what it is. It's additive inverses. So, you should be fine on your homework. We will take questions to start class. Please, if you have issues, mark it on here or be ready to ask questions tomorrow. Keep this homework sheet or the feedback form. We will be using it. Thank you guys very much. Have a wonderful day. Thank you very much. Any other math journals? Stick them in my bin, please.